Hey, what's going on, everybody? You know who it is. It's your boy, Algebra, coming to you live and direct from the living room, aka my studio. Sitting here with my boy, Young Av, watching a little bit of ESPN, some reruns of uh, The Good Doctor from last week. Uh, but I want to take a little bit of time out of our morning to come and talk to you about the product rule. Product rule is a pretty simple but vitally important piece of information to use in our study of derivatives moving forward. And since yesterday you learned a lot more about derivatives, you get to add a rule to it now. That's going to be the product rule. Having said that, Lego. When would I use the product rule is the question. Well, you obviously see the word product in the title, and product means multiplication. I am going to use a product rule on any type of function that has a multiplication problem embedded inside of it. And so I can give you a quick example. If I give you something that looks like this, and I say find the derivative, find the dy dx for that. Most of you guys' first instinct is actually to just FOIL it all the way out. And I have absolutely no problem with that. If you decide to FOIL this thing out, you'll get 12x squared plus 20x in the middle minus 3x. So that's going to be a 17x minus 5. And then you can go and do your derivative from there. So your dy dx in this particular situation ended up being really simple for you to achieve, 24x plus 17. And that's it. So my question is, if I can do that, then what's the point of talking about this new rule? Well, the point of talking about this new rule is because I'm not going to give you something that's quite so straightforward. I'm not going to give you something that you can just go and do the product, or excuse me, just go and do the normal power rule on. I'm going to give you something that has an extra piece of information out there. Something like this times something like that. Again, you could FOIL it all the way out, but that would be 6 sets of parentheses to deal with all at the same time. And that just doesn't seem like a good idea anymore. So the product rule exists because I can't just go ahead and just do the normal problem. I can't just go and figure out using our basic 5 rules that we talked about both yesterday as well as for the past month. What happens if the distributive property is too much work? And that's exactly what this situation right here represents. It represents the fact that you have to do way too much to achieve a small and relatively small result. So the product rule is going to give us a way to take care of that instead. Here we go. Next question. Next question I want to give you is I'm going to say that y equals e to the x times the sine of x. E to the x times the sine of x, you don't really know how to deal with that because you have a multiplication problem. But both of these represent something that's really, really simple. First thing, I want you to identify your first function in there as a, and your second function is b. We may get interrupted by a crying baby in just a second. My homeboy Av is just a little bit fussy right now, and I just heard the poop he laid down in his diaper. You a gross dude, dog. You a gross dude. No wonder you crying, because you stink now. Alright, so we've got an a and a b identified in this problem, e to the x times sine of x. And the basic product rule says if you have a times b then your product rule, the derivative will end up being A prime B plus B prime A. And a long time ago, we said that the prime represents the derivative. So here's what I want to do. I'm going to take my A and make an A prime for it. I'm going to take my B, which is the sine of X, and create a B prime for it, cosine of X. Neither one of those had a chain rule involved in them this time, but I absolutely could do that in future problems. The new formula says A prime times B added to B prime times A. And that's it. You'll be done once you have that product written out. In this particular situation, that combination that we just laid out says that your answer for the derivative dy dx, it absolutely looks more complicated, but that's okay. Derivatives don't always make everything simple. E to the x times sine of x plus e to the x cosine of x. And that's it. So the big idea for today is that you can identify two functions and use them in this product rule. This product rule is an absolute must-have in your arsenal. Hopefully you don't have any questions yet. I'm trying to keep this pretty straightforward. The next example begins now. Next example says y equals, in parentheses for the first one, we're going to go with 5x to the fourth plus 3x. But then in the second parentheses, I'm going to hit you with a e to the x minus 2. And I want to do the product rule on this. As previously stated, it's not good enough to just have one function at a time. I need to be able to give you more complicated situations, and the product rule allows me to do so. Here's what I can identify first. This is my A, and here's my B. Since I've identified them for you, I can go ahead and set off to the task of finding out the primes. A prime in this case is 20x to the third plus 3. B prime, based upon what you were given, B prime is going to be just an e to the x. Remember that negative 2 doesn't actually have any effect on the derivative. My man Av is over here just hanging out with me right now. He's a little fussy. That's okay. Now that you have an A prime and a B prime and an A, we can put those two different pieces together. And remember, you always want to put something together using parentheses because it represents multiplication. Your final answer for this particular problem, A prime, 20x to the third plus 3, times B, which is e to the x minus 2, plus B prime, e to the x, and A, 5x to the fourth plus 3x. Yo, Av, what's up, money? Av wanted to flip around so he could actually see the screen. I guess he's a mathematical genius. My man's over here 8 days old, doing calculus with your boy. That's what's up. If I'm algebra, he must be algebra baby. Yeah, it wasn't a funny joke. I got it. Let's move on. Let's do another example. Let's keep it with all polynomials this time. I want to show you how dense it can become if I start to embed some chain rules into this problem. Y equals 2x plus 5 to the third times 4x squared minus 1 to the fifth. So the difference in this particular problem is your A and B both have a chain rule involved in them. It's not good enough just to deal with that outside x formula. You're also going to have to deal with the inside. So identify your two pieces. A is 2x plus 5 to the third power, which is going to make A prime 3 times 2x plus 5 squared times 2. Somebody says, where did the times 2 come from? Remember that times 2 is that inside derivative part. That is your chain rule. So for letter B, now that you remember to identify the chain rule aspect of it too, B is going to be 4x squared minus 1 to the fifth, which makes B prime. Bring the 5 down to the front. The whole parenthesis stays the same. You drop the power down by 1, but then you do that inside derivative, which is 8x. We're going to use the same information, the same rule again to help us. A prime B plus B prime A. I'll take this 3 and the 2 in the A prime and multiply them together first. 6 times 2x plus 5 squared times 4x squared minus 1 to the fifth plus, there's my A prime and B. Now I'm going to use B prime and A. 40x 4x squared minus 1 to the fourth times 2x plus 5 to the third. All of that together is what I get from my derivative, my dy dx, which is a pretty dope thing. Alright, so with our time left, I want to hit you with one more example. And our last example is going to be quite a doozy, as they say. I'm going to give you another chain rule problem like this one, so it has the extra steps. But additionally, I want to give you some of those other trig functions as well. This is what I'm going to have you doing when I get back to school next week. Y equals e to the 3x squared times the cosine of 6x to the third. That's the actual function, which doesn't mean it has to be very complicated. It doesn't have to mean that there's extra steps. It is a little bit intimidating though. First things first, identify your A and B. In this particular problem, A is e to the 3x squared, which makes our A prime e to the 3x squared times 6x. Your B value is the cosine of 6x to the third. So B prime is going to be negative sine of 6x to the third times 18x squared. So that represents your chain rule. It's not good enough just to use the basic thing. You also have to include that extra piece. Your homework is going to be on a worksheet today, but here is your final answer. A prime B e to the 3x squared times 6x. There's my A prime. My B value is the cosine of 6x cubed. I'm adding that to negative sine of 6x cubed times 18x squared times e to the 3x squared.